Hello, everyone, and welcome to sorry.
These are hard words. Whoever came up with this,
I was the one who came up with this, but okay.
Space Smurfs,
Space Smurfs,
Smurf.
Space Smurf.
Space Smurf.
Space Smurfs,
Space Smurf.
Space Smurf.
Never gonna give you up, never gonna let you down, never gonna run around and desert you.
Hello, everyone, and welcome back to another episode of Space Smurfs Season 3. And you're watching Space Smurfs Season 3, Episode 4. And this is your favorite talk show host, Aleena Joseph. And I know, I got a new haircut, if that's visible, but don't tell me that the previous haircut was better. Tell me that I'm cute in the comments below. Anyway, let's move on to the amazing new episode that we have today. And you are watching Space Smurfs Season 3, Episode 4, like I've already mentioned it. Well, this episode is a bit interesting because of two reasons. One, today we are going to have an expert which you guys suggested while we were planning to launch season 3 last year. So that is one thing. Now put down your guesses on the comments and everything right now. And another thing is that we have been talking about a lot of other things like space medicine, space art, space law and policy, and all such things. But space is also about rocket science and technology, which we usually talk about, right? But what exactly happens in rocket science, and how does rockets work? And I mean, do you know how it technically like lifts from the Earth and goes into the atmosphere and out into the space? Like, do you know the physics, or I don't know, the engineering and all behind it? I don't know. Like, definitely, I don't know at all. So anyway, in today's episode, we are going to exclusively talk about rocket science, and we have an amazing expert joining us today. We have Dr. Ozan Kara here. Dr. Ozan, thank you for joining the call, and welcome to Space Smurfs Season 3.
thank you, Aleena. Thank you for the invitation. And I'm excited to share all the aspects of the rocket propulsion techniques, as well as how rocket works to explore the space, because it's so excited to know about that. It's huge.
Yeah.
You can see many videos of the launches from NASA, SpaceX, and many other institutions, as well as if you want to go to the moon or the Mars, you need the rockets. So
Definitely. Yeah, exactly. And that's the reason why. I mean, right now we have a lot of launches coming up, and we already had a few launches. So people are talking about it, the daily media, like the newspapers, TVs, commercials, everyone is covering all those important news. And do you guys really know about what is happening? So anyway, thank you so much, Ozan, for joining the call. And before we go into the technical questions about, what exactly this rocket propulsion is and how does rockets fly and things like that, our audience would like to know a little bit more about you, what you do in the space sector, your journey into the space sector and all. So over to you. Yeah.
Okay. Currently, I'm in Abu Dhabi, which is a quite nice city in United Arab Emirates, with all palm trees, nice weather, and beaches. I'm working in a Technology Innovation Institute. TAI is a part of government-funded company. So TAI is the under of Advanced Technology Research Council. So there is ATRC and three other subsidiaries. And among all these three other subsidiaries, TAI is the one I'm working on. So in the TAI, we are not focusing on the only space. We focus on the autonomous driving technologies, artificial intelligence, biotechnology, and many other verticals. 10 different research centers. Okay. Among all these 10, propulsion and space, one of the interesting and excited department that I'm working on, and specifically development of a hybrid rocket propulsion system. I will explain what is the hybrid rocket later on, but currently I'm doing this. In addition, I am part of American Institute of Aeronautics and Astronautics, International Astronautical Federation, Space Generation Advisory Council. All these institutions are really important for young people, as well as the people in the space sector, and that's why I'm doing that. But my story began like at the university. I've done a lot of work with pleasure of exploring and the excitement of the space technologies. So that's who am I.
Wow, that's really interesting. And like Ozan clearly pointed out, like all these different, we have been talking about this in the previous episodes also, like organizations like SGAC and, all these other institutions or organizations relating to what you're working on, like they play a major role in shaping up your career and where you end up in the space sector. So if you are a space aspirant who are looking for a space in the space sector, please do join these organizations, build your network, and connect with more people. So, yeah, that's about it. And thank you so much for that quick introduction about you and everything. So, I'll go on to the first question, which is something that I really wanted to ask, like, I don't know, like someone who is working in this area. How does exactly these rockets fly? I mean, I know it gets fired up, there is a propulsion system working, and then you have to escape the gravity and you go into the space. But exactly what is the principle behind a rocket escaping the Earth's gravity and going into the space?
Yeah, actually, as a start, we can define the systems that we generate thrust. I mean, there are two systems, air breathing engines and the rockets. So we, in this episode, focus on the rockets. In order to generate a lift or the thrust to move on in the atmosphere, you use also air breathing engines. What you use is in the planes, you get the air inside a huge chamber with the turbines and the blades, and you expel this hot air into the atmosphere, so you go. And in the rocket systems, however, you store your oxidizer and the fuel inside the vehicle. In the air breathing, you get your oxidizer, which is an air. So you turn it into the hydrogen and you move on. So in the rocket systems, you can see is taking the ball to the wall. When you hit the ball, it hits the wall and it comes back to you, which means the action-reaction principle from the Newton's third law. It's the same. In the rocket, you have the source of the chemicals mostly. You fire it, you burn it, and you expel through your nozzle. Nozzle is the section at the bottom of the rocket, and you create a hot combustion gases into the atmosphere, and then you can lift off. It's like a reaction and action principle. You just throw away your hot and powerful combustion products, and you fly.
Okay, so you're telling me that whole trajectory of the rocket going from Earth into the space, it's because of that energy that is being built up using that thrust that is created?
Yes, definitely. The energy and the velocity of the combustion gases. We call it a propulsive force or a thrust.
Okay, that's really interesting. But that leads to my second question actually. So why does the rocket does not get burned when that combustion is happening? Like you mentioned that all these combustion materials will be going out through the nozzle, and the nozzle, definitely they are made of materials that can catch fire, right? And also, like sometimes we have heard of like I don't know, rockets malfunctioning during its trajectory, and is it because of this, I don't know, the combustion that is happening? And also, like, we would like to know, like, were there any cases where rockets exploded in those kind of situations?
Yeah, actually, it's a good question because someone who doesn't know about the principle on the outside
Mhm.
can see it's dangerous to lift off a huge system through the space.
Yeah.
But you are in a well-designed shape of metals such as
Mhm.
aluminum, stainless steel, or any other vessel, and your working pressure is designed,
Mhm.
and your working pressure is used in the design of these vessels. So in a rocket, you have a really good design and manufacturing system. So that's why you keep this combustion inside that rocket. So you just
Okay.
eject through a single section,
Mhm.
we call it nozzle. So
Mhm.
that's why you are in good shape. But of course, if you design your system that cannot overcome these pressures, you
Mhm.
may see some leakage and you may see some explosion, all the sparks.
Yeah.
That is material compatibility is important. For example, you should know about which chemical you use
Mhm.
and which material you use. A brief example, if you
Okay.
use oxygen,
Mhm.
cryogenic oxygen, we call it liquid oxygen, you shouldn't use titanium. If you merge with titanium in the lux, you generate a flame. So that's why, as an engineer, we are taking care of it. But of course, you ask the situations in real life because, like, we all know the Challenger and Columbia accidents, uh, and astronauts died, and
Mhm.
that was the reason actually. The a ceiling problem, material problem, or that's kind of the design and engineering problem caused that
Mhm.
explosions. And of course, the principles were increased and the technologies were increased. And of course,
Mhm.
if you go for the not launch laboratory experiments, you should also
Mhm.
be careful about all these small, parts that
Mhm.
overcome these hazardous situations.
Okay. That's something very new for me. And well, right now, like all this, like, so you're definitely saying that all these rockets that are being launched from Earth, they come from a lot of niche scrutinying and all those process of testing and finding out whether there are any issues with the combustion materials and whether everything is safe and everything. And once they pass through all those tests only, they are being able to launch from Earth.
Yeah, yeah, because it's like you have a only chance. You have a one chance to
Yeah.
launch. Or if you
Mm.
think about in space, if your
Mm.
satellite or rocket in space going to the moon or the Mars, you have one chance to change it,
Mm.
direction to go to the exact direction, right? That's why
Mhm.
you need to make thousands of experiments, not the hundreds, maybe
Mm.
thousands of experiments for all parts. If you design a small part in a rocket,
Mm.
you need to test
Mm.
it. If you
Mm.
don't test it, you can see the failure because you need to understand how that material reacts during the ignition. So
Yeah.
that's why before the launch,
Mm.
we made hundreds of ground experiments. The system horizontally, we just assemble horizontally, we fire
Mm.
it, maybe
Mm.
uh, hundreds of times, and then we see that, oh, it's okay, it's ready for the vertical experiment. So you change it to the vertical,
Mm.
you make it your simulation experiment, and then
Uh,
you can say that, okay, it's ready for the launch. So before the launch, there are many processes.
wow. Okay, so technically, what we see on the launch day is an outcome of maybe months or years of testings and so many people working behind it from like the designing, the manufacturing, putting all the pieces together. And yeah, it's really fascinating to be honest, hearing about it. Wow. And there are millions of rockets, maybe not millions, but thousands of rockets that are going into space every year. And we are talking about increase in number of satellites and, rocket activities and everything. So, wow, the advancements in the space technology is really impressive. Anyway, moving ahead to the next question, before moving to that, we have our typical Would You Rather in Space by Space Smurfs session done. And Ozan, you may know the rules now. You have some time and you have to choose one from the two options that I'll be giving you. And you can give a brief answer about why you chose an option also. So, are you ready?
Yes. Ready,
All right. Yep. So the first question, would you rather travel to the center of the universe or travel to the center of the earth?
Well, I think the center of the universe,
Mm-hmm. Okay.
because
Why?
I have open space that
Mhm.
I have a chance to see some stars, but
Yeah.
of course, I will probably die to going to there.
Let's hypothetically assume that you have superpowers to travel there and not die, or you can definitely come back to Earth. Let's think that way. Okay, the next question. Would you rather choose to have the ability to resist the space environment or travel through space like the superheroes? Yeah, somewhat connecting to the previous one. Yeah.
Uh, well, it's a tough question, but I like to resist the space environment
Hmm.
uh,
Yeah.
to walk around the Earth,
Yeah.
nothing going too far. But
Yeah.
the other thing is so nice. But yeah,
Yeah, space being a superhero comes with more responsibility. Yes,
yeah.
yes. Yeah, it's too much. Yeah. Would you rather be a Martian or a Kryptonian?
Hmm, good question. I should check the environment of crypto, what Kryptonian, I guess.
Yeah, okay, you can be the next Superman. Yep.
Yeah.
Would you rather meet an alien or be an alien?
Hmm. Well, it's a philosophical question because we are all aliens in the universe, but but of course,
Okay.
like if we have different shapes or different like languages,
Mhm.
well, it's good to be an alien.
Okay, I mean, if that's the case, going back
Yeah.
to what you said, the philosophical perspective, we are already an alien. So, yeah, this is the first time I'm hearing that. Okay, that's interesting. I will look into it. Next question. Would you rather have a holiday to an unknown planet or take a scenic tour to the moon and back?
Hmm. Well, I prefer the holiday
I'm sorry?
because I prefer the holiday.
Okay. You can go to an unknown planet, check
Unknown
what's it.
planet.
Yeah.
You have no
Yeah.
reason to think anything in the holiday,
Yeah.
so
Yeah. And okay, I sense that you're an adventurous person. I mean, moon is something that we know, but you chose to be at in an unknown planet. So yeah, makes sense. And okay, the second last question. Would you rather freeze time or travel through time?
hmm. It's also really challenging question because if you freeze the time, you have if you are not freeze, so it's good
Hmm.
because you can do many things
Yeah.
and you can freeze the time. I prefer that because I can finish everything in just 1 hour maybe. There is
Yeah.
also a nice quote if you check the Interstellar movie, and there is a nice scene that is like dialogue between the two.
Yeah.
In this earth, in this planet
Yeah.
rather, time is different. So there is a nice quote. If you Google it,
Yeah.
they have bubbles, and one is saying that the 7 years of the earth corresponds to 1 hour in this planet. So the other one says like I can finish my PhD thesis in here. So it's good. I remember this
Okay.
nice joke.
Yeah, I mean, yeah, I think there are a lot of PhD uh, people who are working in the space sector, so they can definitely relate to that. And I do have a lot of friends also coming in from that field. So, yeah, understood. And going on, the last would you rather question, would you rather be the first human on Mars or the last human on Earth?
Yeah, I prefer the first human on the Mars because I have still chance to visit the Earth and the swim,
Yeah,
maybe.
yeah,
So
yeah.
it's good.
Yeah. I mean, that part, again, that's something that I didn't think of, that you can still come back to Earth after visiting Mars if the technology is there. Yeah,
Yeah.
interesting. Yeah, that's nice. And well, coming back to all these things and the job that you mentioned, I have one job from my side. It's a dad job. How do planets read books?
How do planets?
Read books.
Ah, good. Uh, I don't know.
Through comic books.
Oh,
I know. I mean, my jock rates are coming down these days. I should definitely step up. It's not getting into that punch actually. So yeah, I'll
I
definitely come up.
these jokes many in my own language in Turkish, but next time I will translate in the English to,
Yeah,
we can make an episode, joke episodes.
definitely. People are giving me this suggestion, so I'm seriously thinking about it actually. But anyway, yeah, I will step up my job game in the coming episode. Don't worry about it, and don't come at me about it. So yeah. Now back to the questions. So you're coming from Turkey, and recently we had a lot of earthquakes happening in Turkey, and Earth observation satellites or space-based applications were used for looking at the amount, the extent of those earthquakes, and for basically like monitoring what is exactly happening in those earthquake happened areas. So I also know that for this year's IAC, you're organizing a panel on looking at these aspects. So I would like to know a little bit more about what it will be about and how are you going ahead with this? Yeah.
Yeah, of course. And like the rocket systems, observation purposes is also really important for discovering the Earth. So yes, we need propulsion systems going to the space as well as operate in the space. But if we go to the space, what will we do? So one of the sections in the space, which is Earth observation. So we observe Earth to prevent diseases, maybe to check the carbon dioxide level on the atmosphere, or water management, and
Yeah.
many other observation we do. So yes, the earthquake on February 2023 happened in Turkey and even in Syria. So hundreds of people died and 10 different cities are affected.
Yeah.
So after these disaster, meanwhile, I was in Turkey. I helped many people there, and we as all group helped many people actually as a society. So it was really good to be united. And after I checked the images from the satellites, taken from the satellites, actual satellites, I made some analysis how to improve these imaging processes, just to prevent some, not to prevent maybe, but just support the data from the structure of the Earth. Maybe we cannot actually prevent that. It's not like 100% early warning, but still it can support the data taken from the taken from the surfaces or underground, and it may be evaluated anyway. So I come up an idea to share in this space sector. So the steering committee of the IAF, International Astronautical Federation, approved my idea. So I will organize a panel and inviting several different people, such as one people from United Nations to discuss the societal impacts of the border, Turkey-Syria border, and psychological perspectives as well. One person from the technical company to discuss the imaging processes, and another two from the NGOs in Turkey who really experience these deserving. So anyway, so clearly I want to mention all the aspects and linked with the imaging processes, how we can create an early warning system or how we can improve that actually.
Yeah, that's just, I would really say that it's a timely discussion that you're doing with IAC or IIF because natural disasters are happening everywhere across the world without any discrimination, let it be US or Europe, Africa, Asia, anywhere you mention, you have one another, like something or another happening when it comes to natural disasters. And I feel like, Earth observation or space-based applications do play a major role in the post-disaster management as well, and also when it comes to risk reduction. So if you're going to IAC 2023 Baku, please do join this panel session with Mr. Ozan here, and it will be really interesting to hear the insights from all these different perspectives that you are bringing in also, like the different stakeholders, the government, the industry, and the people who were actually involved in it. So it will be a really good panel, I believe. So yeah, all the best for you, Ozan, for that panel. And I hope to look forward or hear from it on LinkedIn. I don't know whether I'll be able to join IAC this year, but I look forward to hearing about it on LinkedIn and everything. So yeah.
Definitely. I will share in details when I form the structure of the participants and will share all the information and everything with you. In addition, just quickly, there are many other panels focusing on the climate change by United Nations, or there will be COP28 in Dubai on November. So these all panels that young people actually can follow up to improve their network and awareness about the space as well as the environmental issues.
Yeah, definitely. So yeah, please do check out IAC 2023 Baku page. It's live right now, so you can definitely see all the different sessions that are happening, the panels. So if you want to know more a little bit about the research paper writing for IAC, the cheat codes, the different sessions and everything, last week we had a live session with Antonio from South Korea about this. So it's there on our Instagram channel. You can definitely check it out to know more about what are the different sessions, how can you manage multiple papers at the same time, and how to definitely get into IAC as well. So yeah, please do check it out. And going on, the last question for this session, what are the different types of rockets? We discussed about like all the different ways of engineering a rocket, like from testing and manufacturing everything and to the launch, how it works and everything. But there are different types of rockets, like from defense to commercial, and I don't know the other different segments. And why are there different types of rockets? And also, what is the most preferred type? Or like, are there any other new type of rocket that is being preferred by the whole of the space industry?
Yeah, actually, when we call it a rocket, of course, in order to generate propulsive force, you use different sources. If you use electric or magnetic field, we call it electric propulsion. If you use nuclear fission, we use it nuclear thermal propulsion. So we also have most common type, of course, chemical propulsion. Chemical propulsion, you store your oxidizer and the fuel in a tank. So you create a chemical reaction. And then you generate your propulsive force. So chemical propulsion is more common. And most of the commercial launch vehicles, if you check the SpaceX, NASA, ULA, Blue Origin, and many other companies or agencies. These are the chemical propulsion system and specifically liquid propulsion. So in the chemical, we can also divide into the three. If you are in a single solid phase, we call it solid propulsion and used in the military applications such as missile, because you
Okay.
manufacture a solid propellant using the oxidizer and the fuel mixtures. And if you have liquid fuel and the liquid oxidizer, we call it liquid engines. And all the commercial launch vehicles are liquid engines. So under the rocket systems, we have a chemical rockets and we have a liquid engines, as you can check it out, the SpaceX, liquid oxygen, liquid methane mixture, and many other examples you can see. And there is another type, which is emerging technology. We call it hybrid rocket systems. In this case, you store your fuel in a solid chemical phase, but store your oxidizer in liquid phase. That's why you can use the advantages of both solids and the liquid systems in the hybrid propulsion system. So that is an emerging technology, especially low-cost launch vehicle systems will be used in the future to reduce the cost. Maybe 1/10 reduction will be done in the current ecosystem.
Wow, that's really interesting. So my perception was like, there will be like how we have for satellites, like defense satellites, commercial satellites, and such kind of differentiation. But that's not the case when it comes to rockets. Like it depends upon the propulsion system that is being used. Okay,
yeah, definitely.
that was.
And if you ask how satellite uses the rocket systems, of course, some electric propulsion systems or small chemical propulsion system can be used in the satellites to operate in the space.
Once it goes out from the Earth's atmosphere. Yeah. But that was really an eye-opener for me, like, mainly because I don't come from a technical background. Ta-da. But the thing is, like, I always thought, like, the defense satellites and the commercial satellites, similarly, we might have, like, defense rockets or commercial rockets. But now that I know, okay, it depends upon the propulsion system that is being used. And nowadays, we also have reusable rockets also. I think it was SpaceX who came up with the
reusable rockets. For example, think about you travel from, let's say, New York to Los Angeles by using a Boeing aircraft.
Yeah.
The overall cost is like $80 or $90 million of an aircraft. If you just travel from New York to Los Angeles with a single plane, you spend $90 million, right?
Yeah.
But we use the plane many times. That's why we only pay the fuel cost and the passenger cost, and you can calculate the total amount of the cost from New York to Los Angeles. It's the similar mindset for the rockets. You get the rocket, that as the SpaceX does, they fly and they come back. It's the same principle. So you don't need to manufacture that section, that stage actually. Many times you only the maintenance and the fuel.
And also it depends, and it minimizes the the space debris that is being produced once it goes out of the Earth's atmosphere. Also, right now, space debris is a pressing issue, and you never know what we will have in Space Smurfs. So also, like we might even have a talk on space sustainability or space debris. So if you are interested to know more about these, tune into our channel every month and see what are the topics that is being discussed. Now that we are coming to the end of the session, I also have a quick question, a very short question for you. Since you are someone working in the rocket science or rocket propulsion or rocket building field, what are your few advices for the young aspiring students who want to do something in the space sector, especially the rocket propulsion or manufacturing and things like that? Yeah.
Well, it's a really good question to inspire the students as well as the next generations,
Yeah.
the one thing they can do is follow all the international institutions and try to be member of it and
Mhm.
try to learn which company produces exact systems in every kind of the space sector. Specifically for the rockets, it's good to understand the basic principles, and if they have a chance, they should try some water rocket systems or many, rocket systems they can be built at the home or the
Yeah.
laboratory. So it's
Yeah.
good to have a nice understanding of the principles. So that's really important to gain a hands-on principle in the
Yeah.
future.
Yeah, definitely. And also like the where we have started in the beginning of this podcast, like connect with organizations, connect with these NGOs like SGAC to know more about what we can do. And also we Space Smurfs is also part of APOSA, where we have different segments of things happening, but we don't have a strong rocket propulsion or rocket science related project or anything ongoing right now. But institutions like SGAC and other institutions across the world, they will have more stronger project groups, and you can definitely connect with them all on internet right now. And thanks to pandemic, everything is there on your fingertips these days. So yeah, please do make use of it. And now we are coming to the end of this session, this episode with Mr. Ozan here. Thank you, Ozan, for joining us today. It was really a great conversation to know more about rocket propulsion, what is happening, and how there are different types of rockets there.
Thank you so much, Aleena, for this opportunity to talk and try to, share the knowledge and inspiration about the space,
Yeah.
the, community. Thank you so much.
Yeah. Thank you so much for that. And this is your host, Aleena Joseph, signing out. And till we meet with the episode 5, keep smurfing and bye-bye. Bye.